Good morning, I'm Dr. Huang. Today, I'm going to teach you how to use dimensional analysis method to solve stoichiometry problems. If you see a chemical equation in your problem, always use the equation to organize the information. We put down 2.78 mol below glycerol because when we read the problem, we find 2.78 moles glycerol. We put down a question mark mol below potassium permanganate because when we read the problem, it says how many moles of potassium permanganate. If we organize the information this way, it will be very easy to tell this is a typical stoichiometry calculation problem, because for any stoichiometry calculation problem, you will be provided information of one chemical and you are looking for the information of another chemical. The information can be moles, it can also be grams, molarity, volume, or density. It can also be other quantities we will learn in the future for this class. Now we are done for the first step. Step 2. Put down what you want to convert from on the far left of the paper. We want to convert 2.78 moles glycerol into moles potassium permanganate. According to the instruction in the flow chart, we need to put down 2.78 moles glycerol on the far left of the paper. Step 3. Put down the unit we are looking for on the far right of the paper. We are looking for the moles potassium permanganate. According to the instructions in the flow chart, we need to put down moles potassium permanganate on the far right of the paper. You may have already noticed I put down a chemical formula behind the unit. The reason I put down the chemical formula behind the unit is moles glycerol is different than moles of potassium permanganate. If we put down the chemical formula, we can avoid miscancellation. Step 4. Put down all possible conversion factors. All stoichiometry calculations need conversion factors from the balanced chemical equation, since we want to convert from glycerol into potassium permanganate. So we need conversion factors which include both. This is one conversion factor from the balanced chemical equation. This is another conversion factor from the balanced chemical equation. To find a conversion factor from the balanced chemical equation is quite easy. 4 moles glycerol. So we put down 4 moles glycerol. We say 14 moles potassium permanganate. We put down 14 moles potassium permanganate. 1 on the numerator, 1 on the denominator. I put down mol between the number and the chemical formula. This will remind me this is a ratio between moles, not grams. To get another conversion factor, you just need to flip the numerator and the denominator. Step 5. Pick a conversion factor and multiply what is on the left side of the paper. We want to cancel moles glycerol. So we need a conversion factor which has moles glycerol at the bottom or as denominator. Can the unit cancel? Mole glycerol at the denominator and mole of glycerol on the numerator. They will cancel according to the mathematical rules. Do we get the desired unit? The unit we are looking for is mole potassium permanganate, and the unit we have left right now is mole potassium permanganate. Bingo! Well done! All we need to do next is we punch all the numbers into a calculator. 2.78 multiply 14 on top, divide by 4 at the bottom. The calculator says the answer is 9.73. In order to earn the full credit, you need to show all I have here. This is called work. This is the flowchart to use dimensional analysis method to find a solution for your problem. It tells you what to do first, then it tells you what needs to be done for each step until you find a solution for your problem. We will use this flowchart to solve stoichiometry-based calculation problems.